So looking at the chapter 8.1 homework here, we're going to start out with number 33. So we're looking to graph this function. When I'm looking to graph this thing, there's a couple things I want to pick out first, and that's the a, h, and k values. I'll also look at my b value. So when I'm looking at 33 here, my a value is negative 1/5. If you want to represent this as negative 0.2, that's fine as well. My b value here is 1.5, and the big thing to note here is that that b value is greater than 1. My h value, oops, I'll actually write it up here a little bit. So my h value is 0. My k value is 0. There's no horizontal or vertical shifts happening here. And then I want to note that my exponent is positive. So here I have a b value greater than 1 with a positive exponent. That means this thing's going to be exponential growth, and I say that kind of. Now kind of is because this a value is negative. So since this a value is negative, it's not actually exponential growth. So since this a value is negative, it is not, but if it were positive, then it would be. So again, b value greater than 1, positive exponent, but since it's got a negative a, we don't really refer to it as exponential growth or exponential decay. It's just a graph. But it essentially looks like exponential growth flipped over that y-axis. So let's look at graphing this thing. So I want to start out at h comma a plus k. So this is going to be my starting point here. Now looking at this, my h value is 0, so this is going to turn into 0, comma, and now here's a plus k. My a value is negative 1/5, so I'm going to put this as negative 0.2. And the reason I'm going to do this is because I'm going to round all these values to the nearest hundredths place. So when we're doing graphs like this, and like when I'm asking you to do them on a test, we're going to be rounding these values to hundredths place. So I'm going to just call this thing 0.2, and we'll kind of switch to decimal mode. So when I'm looking at this, I'm saying, okay, it's going to start at 0, comma, point negative 2, or excuse me, negative 0.2. And then from here, I want to go 2 points to the left and 2 points to the right. So now I'm going to set up my t-chart. And so I'm going to say this is x, this is y. Oops, there we go. I'm going to stick that 0, negative 0.2 right in the middle. And I'm going to use negative 1, negative 2, and I'll also use 1 and 2. So when you're evaluating these things, again, we're just taking the numbers and plugging them into the equation. If you want to have your calculator do this for you, I'd highly recommend that. If you have a graphing calculator, it can also make your life easier just to enter the values like that. You can do y equals and then enter it in, and then you can just do second table set, and then you can find the values that way. If you don't have a graphing calculator though, it's not the end of the world. You're just gonna end up plugging the thing in a couple times. So let's see, I'm gonna set my stuff up here. And I'm gonna write my approximate values. So for negative 2, I'm gonna call this thing negative 0.09. For negative 1, I'm gonna call this thing negative 0.13. For 1, I'm going to call this thing negative 0.3, and then for 2, I'm going to call this thing negative 0.45. So it's pretty difficult to see like what is happening here, but I'm going to do the graph regardless, just so we can kind of take a peek at what it is doing. So this thing is going to be getting very, very close to its horizontal asymptote. So let's actually call that out before we do the graph. That'll make the graphing a little bit easier. So here we get a horizontal asymptote at y equals k. Now k value here is 0, so we're going to get a horizontal asymptote at y equals 0. So here I'm going to just kind of draw a line. I know it's not directly on here, but that's supposed to be y equals 0. And I know this thing's going to approach it, but it's not going to actually touch it. And that's going to be as it reaches out to negative infinity here. So as it goes out to positive infinity, this thing's going to kind of shoot downwards like this. So in graphing these points, again, kind of do your best to graph them. I don't know, 1, 2, 1, 2, 1. So again, all these are going to be approximations. I'm not going to be able to do any like really nice graph. So we'll say a point there, point there, point there. We're starting to get a little bit more negative here, so I'm going to try and represent that Obviously, I'm exaggerating it a bit, but that's okay. And so my graph for this thing should look like it's going to approach 0 there, and it's going to start shooting down to negative infinity there. So when I talk about the range on this thing, domain is all real numbers. I can plug in anything I want. The range on this thing is going to be y is strictly less than 0. So it's always going to be less than if the a value is negative, and it'll be greater than if the a value is positive, and it's relative to that horizontal asymptote, which is just at y equals k. Any questions on this one? Perfect. These are very good problems here. I like this little chunk. Start with the given information. So we want to have 2,500 after 2 years. So we want to find the amount that we should be depositing for each of the given situations. So when I look at this value, what I'm saying is that the amount is going to be equal to, actually I'm going to use a different color so I'm not confusing it with the red underline here. So the amount will be equal to my principal investment times 1 plus r over n raised to the n t. So this is my compounding interest formula here. My a value right here is 2,500. And now for my t value, that's going to be 2. Let's do this. So the other values here are going to change a little bit. So my r value and my n, actually I'm going to color these. So let's do r is blue. And we will say our n value is purple here. And so now when we say n, n is the period. So this thing is compounding monthly. That makes my n value here 12. Here I'm compounding quarterly. That makes my n value equal to 4. And here I'm compounding yearly, which just means my n value is 1. Now in this scenario, if you wanted to simplify this thing and just do p times 1 plus r and then raised to the t, you could. But let's just leave it as this because we're going to just enter 1 and 1 here. It's going to simplify, but we'll keep with the same setup. So looking at the first one here, we'll do 62. So looking for 62 first, the account pays 2.25% annual interest compounded monthly. So what that means is that this one is going to look like 2,500 is going to equal, I don't know what that p-value is. That's the thing I'm trying to solve for. 1 plus, here my r value is 0.00, oops. I was going to do 0.0, but then I changed my mind. So here, again, anytime I want to go from a percentage to its decimal, I can always just divide it by 100. So if I did 2.25 divided by 100, I get 0.0225. And then that's going to be divided by n here, which is 12. And then that's going to be raised to, and now here's my nt. So now here's going to be 12 times my t value, which was 2. So I'm going to rewrite this thing. It will look like 2,500 equals p times 1 plus 0.0225 over 12, all raised to the 24. Now this is exactly how I would leave it on my calculator when I go to evaluate it. So I'm going to enter this stuff in. I'm going to represent it with an approximation for you, but just keep in mind that when I'm actually doing this, I'm going to leave it as that yucky number, and then I'm just going to do 2,500 divided by whatever that is. So I'm going to do an approximation for that now. Let's see what we get. So we get 1 plus my 0.0225 over 12 and that's all being raised to the 24. Excuse me. So this is going to give us approximately 1.0459 8. Okay, so I'm just going, I don't know, 5 decimal places because then I kind of ran out of space here. So again, I'm not going to actually be dividing by this number. I'm going to use the number which is in the calculator, which is approximately 1.0459838787, right? So this again is just to represent what that number is here. So this big chunk turned into this thing here. Now I'm going to divide both sides. So divide both sides by that number, and I get that my p-value is going to equal approximately 2390.09. So again, rounding to the hundredths place because that's my nearest penny here. Any questions on this one? Perfect. Okay. So for the next one, the only thing that's going to really change about it is the fact that now I have a different interest rate and I have a different compounding. So here's all the nice color coding. I'm going to jump to the next one, which is just going to be all in one color, hopefully able to follow along. So for the next one here, 2500 is going to equal P times 1 plus, now I have 0.02 over, and now here's going to be 4. Now it's going to be 4 times 2. So again, the only part of this stuff in parentheses is being divided by the period is the interest rate. So don't do the 1 plus 0.02 and then divide that by 4. That's one mistake I see people make. So now I'm just going to simplify this thing. 2500, whoops, equals P times, and now again, I'm going to write an approximation for this. So again, take it one step at a time. My recommendation is to just do everything as one kind of process on the calculator. I don't recommend breaking it up and rounding at every step. That's how you kind of introduce layers of like approximation, and then it starts becoming more and more off. So here I'm going to set this up. So 1 plus my 0.02 over 4. That thing's being raised to the 8th, and I get approximately 1.040707. So again, an approximation here. So I'm going to divide both sides by that number, and I get my p-value to be approximately, call it 2402.21. So now let's pause for a second and compare these two numbers. I need to invest more with this second one than I did for the first one. And the reason is the first one pays a higher interest rate and it compounds more frequently. So let's say these two were actually both 2%. Even if these were both 2%, the first one would still accumulate faster because it's compounding monthly. And so I would have to put less in to have that 2,500 in 2 years. Let's see, one more color here, purple. It's gonna be a little bit squished, or it's gonna be pink. Hopefully it's not too bad. I'll kind of box it off. So here now, same setup, 2,500 equals P times, now here I have 1 plus 0.05 divided by 1 raised to the second. I mean, you can do times 1 if you want, but yeah. So again, with this being annual, it's only happening once, so there's the 1 value. So now I'm saying 1.05, and this will give me a nice exact answer. So 1.05 squared gives me, so call this P times 1.1025, and now I'm going to divide both sides by that 1.1025. So let's do that. And we get our p-value to be approximately 2267.57. And we are good to go. So we see this here, even though it has a lower frequency of compounding, so yearly is going to be the slowest compounding here, it's got the highest interest rate. So that's offsetting, and this is going to be kind of my best choice. So if I had an option of which of these to choose to invest, I would choose number 64 here. Any questions on that one? Perfect.